Finally, we have what I dub the weird ones. Now, there's a reason for this because our previous few theorems have all kind of had ties to what you learned in algebra. However, we start to get to these weird ones, and it's only when you examine these from a gate structure that you really start to put two and two together. For our first one here, I'm just going to actually start drawing the gate out. We have an AND gate here first, and then that feeds an output of an OR gate here. We are going to feed the output of the first one a value from our x as well. So you can think of it as being tied into it. So here we would have x and here we would have y. Now, the output of this is always going to be x. And when you write this, it looks a little funny because you say x or x and y is always x. It doesn't really quite make sense because you're kind of looking at it and you're like, oh, well, but I mean, I see the answer, but I don't. So let's go ahead and let's play with this equation for a second here. So let's go ahead and do the same thing, but we're going to put values in for this time. We're going to use ones and zeros. So let's say we have a 0 for both x and y. How does that turn out? Well, we have 0 or 0 and 0. Going to be 0. Let's try this though. If we have a 1 for x or a 1 and a 0, this becomes a 0, but this 1 or 0 is going to be 1. That just pretty much proves our theorem there. It's, like I said, one of those things where sometimes with these, you got to just work them out on paper and draw the gates out, and then it makes sense.